So electric field, it is region around the charge where charges can feel the force or electrical force. So space around the charge where the charges can experience the force or feel the force, that space is known as electric field. Like example, if I place a proton and next to this I place another proton. So what will happen? These are, because protons are positive or like charges, what these like charges will do? So like charges, they will repel each other. So these are like charges or identical charges, and what identical charges will do, they will repel. So when these charges will repel, they try to push each other. So the space, the region where these two charges can exert force on each other, that whole region is known as electric field. So space around the charge where other charges can experience force, or region around the charges where they can exert force on each other. So simple definition of electric field: a region in which electric charges experience force, that is called electric field. But how we represent this electric field, because this is not the way we represent electrical field or electric field. So how we represent this electric field? We represent this electric field by lines. So electric field lines are used to represent electric field. And how we draw these lines or how we represent, example, if there is a positive charge, if you place a positive charge and next to this we place another positive charge, which direction this small positive charge will move? Towards the positive or away from positive? So this small positive charge will move away. So what is the direction of electric field? So direction of electric field is out from positive.
In all the directions?
In all the direction, because if I place a charge anywhere, which direction this charge will move, it will always, if I place a small positive charge anywhere, which direction it will move, it will always move away from the other positive charge. So that's why the direction of electric field is always considered out from positive. But if there was a negative charge, if there is a negative charge and we place a small positive next to this, which direction this positive charge will move? So this charge will move towards, the small positive charge will move towards the negative charge. So what we assume that the direction of electric field is always into negative. And what is the direction of electric field? Direction of electric field means it's a direction It is direction in which positive charge moves. So direction in which the positive charge move, that is always refers to direction of electric field. That's a standard. So both of these charges exert force on each other, but a small positive charge tend to move towards the negative charge. That's why we say direction of electric field is into negative and direction of electric field is out from positive. So if a question is draw electric field lines for a positive charge or for a negative charge. So positive charge, you should always draw the arrows outward, and for negative charge, you will always draw the arrow inward. The strength of electric field is represented by distance between the field lines. If lines are closer, it means stronger field. If lines are far away from each other, it means weaker field. Example, you have two positive charges, okay? One is small positive, another one is large positive. A small positive having example a weaker electric field, and large positive is having a stronger electric field. So how we represent in terms of field lines that which one is stronger? Both of them, because the direction of electric field is always out from positive and into negative. Why? Example, maybe here we have more positive charge. Say example, this was 3 positive and this is only 1 positive. Why it's not necessary that the size will decide the field. It depends on how many positive charges are there. Example, this sphere is having 5 positive charges. This is having only 1 positive. So greater the number of positive charges, it means stronger electric field. This one is having only 1 positive charge, so weaker electric field. The size will not decide, the charge will decide whether it is stronger or weaker. Just to give an idea that I drew them with different size, but it can be small size but with a greater charge, so it can have a stronger electric field. So size is not the factor here, the charge is the one which decide the electric field. So what is the direction of electric field? The direction of electric field is always out from positive. Because the direction of electric field means it is a force experienced by positive charge. Means if I, or it is a direction in which the positive charge will move. Because this is having greater charge, so I have to draw more field lines. Because when greater number of field lines, what it shows the strength. So it shows that this is a stronger electric field. For this small positive, direction is same, it is out. But what will be the difference in electric field? Because smaller charge, so it shows that it is having a weak electric field. So this is how we represent the strength, that drawing more field lines. If field lines, you can see here, the field lines are closer, means a small gap between them. So field lines having smaller gap, it means stronger. If field lines having greater gap between them, it means it is weaker. Is it clear, the idea about the strength of electric field? So if I place a positive charge, where it will move, which direction it will move, A or B? If I place a positive charge, which direction it will move? So it will move towards A. So basically, positive charges move as same as the direction of electric field. But if I place a negative charge, where it will move? A or B? If I place a negative charge, so negative charge, because unlike charges attract each other, so negative charge will move towards the positive charge. So the idea is that positive charges move same as direction of electric field, where negative charges move opposite to direction of electric field. You can see here, this is as you know, the like charges, they will repel, and unlike charges attract. So you have a positive charge and you place another positive charge. So these are like charges. What happened? Like charges will repel. So as the like charges will repel, so this positive charge will move away from another positive charge. So which direction it is moving? It is moving same as the direction of electric field. So it's moving away. But if I place a negative charge, unlike charges attract, so it means the negative charge will move towards the positive charge. So which direction it is moving? It is moving opposite to direction of electric field. So same way, if we are having a negative charge, if we have a negative charge sphere, so what is the direction of electric field? Direction of electric field means direction in which the positive charge will move. That's called a direction of electric field. So for negative charge, the direction will be in. Which one represent a strong electric field?
The first one.
The first one, because the field lines are closer, so shows that it is a strong electric field. So if I say this one is A and this the second one is B, so A is representing the strong electric field. Where B is representing the weak electric field. Now, if a question is you have a positive charge and you have a negative charge, which direction the positive charge will move? So positive charge attracted toward negative. So positive charge will move toward negative. So you can see the movement of the positive charge is same as the direction of electric field. But what about negative charge? It will move away. And same thing, if we have a positive charge here, it will move towards, and you have a negative charge, it will move away. Which negative charge experience stronger force, A or B? Like which negative charge, or negative charge 1 or negative charge 2? Which negative charge experience stronger force? So negative charge 1 will experience stronger force because electric field is stronger, so the force will be greater. If electric field is weaker, that means the force will be smaller. So force experienced by the charge also depends on the strength of electric field. Stronger electric field means greater force. Weaker electric field means smaller force. And how you can increase the strength of electric field? By having more charges. Greater the number of the charges, stronger the electric field. It can attract objects, charge object with a, or attract or repel charge object with a greater force. So you have to learn certain electric field patterns. If a question in exam, they say, draw electric field for proton or positive charge or positive charge sphere. So how you will draw this? As we know, proton or positive, all are positive, so we'll draw that particle. Example, if I'm saying proton, so I can write P or I can write plus charge on it. Then what will be the pattern? Because proton is positive, so direction of electric field is always out. And if the question is draw electric field for for electron or negative charge or negative charge sphere, so we have electron. Electron itself is negative, so what will the direction of electric field? It is towards or into, because the direction of electric field means direction in which, if there was a positive charge, which direction the positive charge moved, that's called a direction of electric field. This is if they say negative charge. And if you want to draw electric field pattern for parallel plates, or electrodes, or capacitor, it's the same thing. So for parallel plates, electrodes, or capacitor, how we draw the electric field? Example, you have two plates. One is connected with how to identify the terminals. The big line of a cell represent positive terminal and small line represent negative terminal. So this will be positive. And the second one is negative. So what is the electric field pattern? So it's always from positive to negative. So it's the field lines when you represent from positive to negative. Parallel field lines, like equally spaced field lines. Near the edge, a bit curve, but between the plates, it should be parallel. If I place a proton here, which direction it will move? Right or left? Proton.
Left. I mean right. I mean
Right.
to the negative.
Towards the negative. So proton will move towards right. And if I place electron here, which direction it will move?
Anodes.
If I place electron, it will move towards
To
the
the positive
positive left hand side. So basically the direction of the positive charge, movement of a positive charge is same as direction of electric field, and electron moves opposite to direction of electric field. This is if they say draw field lines for parallel plates. So between them, equally spaced lines, and near the edges it will be curved, directed from positive to negative. If you have two unlike charges, two opposite charges are there, like example, one is positive, another one is negative. So electric field is from positive to negative. So how you
Why
represent?
not in all the directions?
Because the direction of electric field means it is a direction in which the positive charge will move. That's a standard definition for electric field. It's a direction in which the positive charges move. So if I place a positive charge, which direction that positive charge will move, that is known as the direction of electric field. So if I place a positive charge close to negative, it will move towards negative. So means if we have proton here, it will move in this way. But if we have electron, it will move in opposite way. The direction of electric field is always the direction in which the positive charges experience force or positive charges moves. So if you have unlike charges, two opposite charges, the direction is from positive to negative. If I want to make a stronger, so I will draw more field lines. If I want to show a stronger field is there, so I'll make more field lines which shows that the force is, or field lines are closer and the force is stronger. You have to practice these patterns of electric field they ask to draw electric field either for positive charge, negative charge, unlike charges, two electrodes as well. Yeah, isolated positive charge, I already did this. This is called isolated positive. Isolate means like only positive charge is there. This is a one which I drew for proton or positive charge. It means it's an isolated positive charge. Isolated means the charge is not with any other substance.
Sir, there is no fixed pattern for it. Like,
No, there's a fixed pattern for positive. We drew like from positive to negative. This is a way how you draw the electric field lines. This is a pattern which you have to practice. If there is a positive charge, it will point outward. If it's a negative charge, point inward. Negative charge or isolated negative charge or negative charge.
like how many arrows should we make?
No, that is different thing. That is the strength. Number of arrows are representing the strength. That is up to you how many arrows you want to draw. But there's a pattern. It's from
Yeah.
positive to negative. Number of field lines which you want to draw, that is variable. Like some student maybe draw 5 field lines, some will draw 6. So that can vary from student to student. And if two like charges are there, or identical charges are there,
Repel.
the like charges repel, so they try to cancel out their electric fields. So
Yeah.
as they try to cancel out the electric field of each other, so if you have this one as a positive and there's another positive, so as they try to cancel out, there will be a region where there is no electric field. So, and these are the positive charges, so electric field lines are pointing out. So between them, they try to cancel out. So how we represent this, how they cancel out, we represent by curve here. Shows that they cancel out each other electric field. So there is no, like you can see this region, I did not draw any electric field line. Means if I place a charge here, that charge will not either move towards right or left. Like if I place an electron here, which direction this electron will move? Towards right or left? Which direction this electron will move? This electron will not move. Why it will not move? Because this region, there is no electric field. There are no field lines. So it will stay at its position or it will not move. Same way, if I place a positive charge, because there is no electric field lines, so this positive charge will remain at its position. It will not move. Is it clear? The idea that the two like charges, they try to cancel out the electric field of each other. So between them, there is a region, there's a place where there's no electric field. And if there's no electric field, means charges will not experience any force here. But instead of two positive, if it was two negative charges, then the same pattern will be there. The pattern will be same, only the arrows are pointing in. So if we have two like charges, but this time the two identical charges are negative, so arrows will point in. And between them there is no electric field. But the arrows, this region, So if I place any charge here, this charge will not move. So these are the patterns which you have to practice. The electric field pattern. Now I'll discuss some question related to electric field. And in the second session, I will do some question related to topic light, because we did not solve many questions related to light. So first MCQs, multiple choice question. What is electric field? What's the answer? What is electric field here? So B is the right answer. Basically, it's a region where electric charges can experience force. A region around where current carrying conductor compass needle experience force, that's called magnetic. Region where electric charges attracted by electric charges are by the earth gravity, then it's called a gravitational field, not electric field. A region where electromagnetic radiation can pass or is passing, that's called a medium. That is not called a field. Question 7. The diagram represents two different electric fields. A single electron is located in each field, means there's electron here and there's electron here. Which row give the correct direction of the force on electron, and there's a large force on it. Direction of the force refers to direction in which the electron will move. So which direction this electron will move? Electron is negative charge. Electron is negative charge, so electron always move opposite to direction of electric field. We already discussed. So electron does not move same as, if electric field is up, electron will move opposite. So downward, both cases it will move down. And which one is stronger field? Because you can see the field lines are closer. So A is the right answer. Is it clear, this question? If the same question, they change the question, if they mention, yes, Salman. You can use the chat, or yeah, actually this field is like, you have a positive charge because it's a parallel, so it means this is due to electrodes, and this one is negative. This is similar to that one I drew. You can see here, so it's parallel one. It's, so instead of drawing in a vertical plane, you can draw in this manner. So you have positive and negative, and the field lines are parallel to each other. It shows it's because of plates. That's why the field lines are parallel to each other. But one is stronger than the other because more field lines. So if I place electron here, so which direction this electron will move? This electron will move downward. So same thing was there in the question, that this electron moves downward. So this electron moves downward, and because the field lines greater gap distance between them, so this shows it's a weaker electric field. Figure 8.1 shows a high voltage supply is connected across the two metal plates. what is meant by electric field, and draw the electric field line between the plate and indicate the direction. So what is meant by electric field? You should write a standard definition for this. It is region around the charge, or it is a region where electric charges can experience force can experience force, and its direction is same as force experienced by positive charge. So it is a region where electric charges can experience force, and the direction is always same as direct force experienced by positive charge. Why it's of 2 marks? One is mentioning a region where electric charges experience force, and the second one is mentioning a direction. It's from positive to, or its direction is same as a force experienced by positive charge. The second one, draw on figure 8.1, draw electric field lines between the plate and indicate the direction. So how will indicate? Because left hand side is positive, so it should be and keep in mind, like if you parallel line should be there and equally spaced. If you draw like this, means you will lose the marks. Why it is of 2 marks? One is for representing the field correctly, like parallel lines, equally spaced lines, and the second mark is for the direction. Near the edges, you can draw curve. Is it clear? The electric field lines.